We had a video earlier called Alternating Vector that was about making a vector 1, -1, 1, -1, okay, and so on like that. And there's one obvious way to try to make this vector that I didn't want to do because in the back of my head I thought that because of numerical precision it wasn't going to work, even though it was a reasonable thing to try. And what's the idea behind it? Well, what's a function that alternates back and forth? Okay, that oscillates between different values. So the one we used before was -1 to the x power. Okay, but that's actually not a very normal function. For example, -1 to the 1/2 power, that's not defined unless you're in complex analysis. So a much more common function that alternates back and forth between 1 and -1 are the trig functions like cosine and sine. So let's try to make this alternating vector of 1s and -1s using cosine and sine, and then I'm going to point out how it doesn't quite work because of numerical precision. So let me make a function, let me call it ALT for alternating vector. Input is going to be n is going to stand for the length of the vector. Output is going to be the vector v. And here's how I want to make it. Let me first make a vector 1, 2, 3 up to n. Okay, so how about w equals 1 up to n? And then I'm going to multiply it by pi. W equals pi times w. So what that says is go through each entry in w and multiply it by pi. And then let me apply cosine to it. So v, which is our output, is going to be cosine of w. And this isn't quite going to be what I said. I wanted it to go 1, -1, 1, -1. But cosine of r times pi, well, if r is even, I get 1. If r is odd, I get -1. So I really want to start with an odd number. I really want to start with an even number if I want to start at 1. Okay, if I want the output to be 1, then I want the input to be something like 0 or 2. Okay, so instead of going from 1 to n, let me go from 0 to n minus 1. Okay, now this should work. I'm going to save it. And now let me do Alt of 20. Okay, and that looks like it worked. For example, let me try a and s, which is the variable name that was stored for it, since I didn't specify another one. Let me ask, does the fourth entry, does that equal -1? Okay, remember to use two equal signs. Yep, I get true that it does. What if I want to test the last entry, the 20th entry? Well, here's the reason why we shouldn't use this a and s variable name very much. So a and s, I think that stands for this length 20 vector, but as soon as I did this last line, this line here, the return to logical entry, then the old value of a and s got overwritten. Now its value is just this length 1 thing, here 1. So when I try doing this, I get an error and say there is no 20th component because a and s to the computer, it's now just this number. It's forgotten that it was originally this length 20 vector. So how should I have fixed it? Instead of doing just alt 20, I should have done something like v equals alt 20. Okay, and then once I've done that, I can do something like, does the 20th entry in v, does that equal -1, true or false? And I get true. So it seems like that works, but in the back of my head, I know that it's not going to work eventually for some number because of numerical precision. Because here, this pi, that's not represented exactly in MATLAB. There's some rounding that's going on. So if instead of going up to 19 for my w, if I'm going up much higher, then I have the impression that it's going to stop working at some point, that it's not going to be exactly equal to 1. I'm going to write a script to help me test when does this function stop working, when does it stop giving me what MATLAB says is exactly 1 or exactly -1, alternating back and forth. So let me go back here and make a script to help me do this. And I'm going to start with just some value, a equals 0. And then I'm going to ask while cosine a times pi. And I'm going to choose it so that a is always even. So this cosine of a times pi, that's always going to be positive 1. Okay, so while that's 1, so this is like saying while MATLAB is working correctly with the numerical precision that I want, then I want to make a bigger. And instead of just going up by 1 at a time, I think that'll take too long, let me go up by 10,000 at a time. So how do you make a bigger by 10,000? You do a plus 10,000. A equals a plus 10,000. Okay, and then when that's over, so when is it going to leave this while loop? It's going to leave this while loop when MATLAB registers that cosine of a times pi is not exactly equal to 1. So that'll be the first value of a that it's found, where the numerical precision, because of some rounding error, says it's not exactly equal to 1. So I'm going to want to know what's the value of a where it stopped working. So I'm going to say display a at the end. So let me call this test. How about alt? Maybe I should have called it test cosine, but this works fine. So let me try it. Test alt. So what is this saying? This is saying, how much is it? It is 27,300,000. So if I do cosine of 27,300,000 times pi, so some even integer times pi, and I ask, does that equal 1? Then MATLAB says false, it doesn't equal 1. If I try, how about 27,200,000? Then I get true. Cosine of this big even integer does equal 1. Okay, so that's how I used a script in MATLAB to find where the rounding errors started to show up.